horizontal transformations. Alright, so I'm going to write a bunch of words up here this time, and it's best to write them down, and they're not going to make a lot of sense until I show you some examples. And then, I want you to be able to go back in your notes and read this later on. And it's similar to the vertical. Consider a function y equals f of x let k be a positive real number. Then we're going to have two things, similar to the way we did vertical transformations. With vertical transformations, we had a plus k or a minus k on the outside of the function. And that worked the way we thought it should work. If you had a plus k on the outside, that means it goes up k units. If you have a minus k on the outside, it goes down that many units. Here is not going to work how we think it should work. It's not going to be intuitive. And I'll show you, for example, here. On the first one, the graph of y equals f of x plus k. So the difference here is the k is now inside of the function. As before in vertical, it was on the outside of the function. Now we're inside. So when we're inside of the function, it doesn't work the way we think it should work. And that is the horizontal. The horizontal is the graph of y equals f of x. So y equals f of x plus k is the graph of y equals f of x shifted which way? It is the graph shifted, plus k means to the left. So it works opposite of how we think it should work. Shifted left k units. Alright? Remember, if it's inside the function, it works opposite of how you think it should work. And similarly, I'm going to draw a line. That just means copy what's above. Y equals f of x minus k. It's inside the function. That means it's going to work opposite of how I think it should. So that's going to go right k units. Is the graph, let's draw a line here for that part, is the graph of y equals f of x shifted right k units. All right, let's look at some examples. Pause the video if I'm too fast there for you. All right, example 1. Let's just say graph, just to be shorthand here. Graph the following. I want you to write the parent function, write the shift that's happening, graph the parent function, and then graph the shifting. It's all just good practice and will help you remember these things. Okay. So g of x is equal to x plus 2 squared. All right, so what is the parent function here? So blank out what's not supposed to be there. So if that plus 2 wasn't there, then you would have x squared. That's the quadratic, x squared. So parent is, we're using g here, let's use h for the parent, is x squared. That's the quadratic. And so we're inside of the function, that means it's the horizontal. All right, when we're inside, it's the horizontal, and it works opposite of how we think it should work. When it's on the outside, it's vertical, and it works the way we think it should work. All right. So we are inside, it works opposite of how I think it should. So we're inside, meaning that's the horizontal, and it's opposite of how I think it should work. It's a plus, so that means it goes left. Left 2 units. Now let's graph that parent function. Parent function is x squared, so I know I have 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And this is h of x. Now I have my parent function drawn, and I'm going to move left 2 units. So I take these points and just count 2 over. 1, 2. There's my new point. 1, 2. 1, 2. And here is my new function in yellow, and that is g of x. All right, let's try one more. B. Call this one f of x is equal to the square root of x minus 3. So try this one by yourself. Go ahead and pause the video. Parent function is m of x is a square root. I'm going to call it m of x is equal to the square root of x. And the shift, okay, it's inside the function. If it was outside, it would be out here. So it's inside, so that's the horizontal, and it's going to work opposite of how I think it should work. Minus 3 means to the right. Shift, right 3 units. Here's the x-axis and the y. And to draw the parent function square root of x, I get 0, 0, 1, 1, 4, 2. That's m of x. Now we apply our shifts. We go to the right 3 units. We take each point and move. 1, 2, 3. 1, 2, 3. 1, 2, 3. And here is your f of x.